Okay. Hello, everyone. Good morning, good afternoon, good evening, whatever time zone. So welcome everyone for this is our fourth day of the swim workshop and conference. What I'm going to do is I will go over some of the what we learned for this 4 days. Today is the fourth day. We started on Monday for workshop. We called Monday workshop. So I want to brief you. Some of you may not have joined all. So that's what I'm going to do is give you an overview where we are. And today is our last day of the swim conference. But that doesn't mean we don't have a star lineup of the speaker panel. A lot of things are there. And also I want all of you to stay until end because we need to talk in the panel. Walter Graf will be leading that panel, and I will go over that in one of the slides. Where we go, what's the path forward? This is not like a typical conference. We organize this based on the theme. So if I can move my slide. So let me ask before Kathy, you can see my slide and hear me well, right? You guys can see my slides or no?
Yes.
Yes.
Okay, perfect. Okay, so this is what the workshop was December 7th, and then we held this Smart One Water. We targeted a Smart One Water because of NSF initiative. So that's the beauty of this swim. Every year we do. I mean, this time we had to go virtual, but previous years we have done this in our Arlington facility in Northern Virginia. And most of you have attended that. So swim conference, we are running this for 10 years now. So we always go with whatever our board decides, but also with the current topic. What's the emerging topic? We select that and we do. This year, we tried to go with NSF initiative because last year we got the National Science Foundation Smart One Water initiative. So ERC is, let me explain you a little bit, it's an engineering research center. So it comes every 5 years, they fund, and it's like a long-term funding. It's not like a typical project. They fund for 10 years. It's a big investment from federal agency. They want to have a societal impact. It started in 1986, this whole NSF ERC, mainly to support manufacturing because Japan at that time lot of manufacturing. So that's what it started in US is how to support US manufacturing. So that was generation 1 ERC in 1986. Now we are generation 4. What that means is generation 4 ERCs, and I will show you, there are different pillars to it. It's not just the research. So we submitted this last year. We got for Smart One Water, cyber physical social infrastructure to create and work with all stakeholders. We have a website, and most of the information we will put it there once this conference is over, and you will get a notification from Kathy. It takes some time to compile all, to get all presentations and put it on the website. So it will all go to smartonewater.org website. So if you can Google it. If you go to this website, you will see the previous workshop we held. So all information we are going to upload there. So what's the concept of one water? When we say, a lot of people, some call integrated water, one water, whatever term we use, the whole thing, what we have proposed to NSF is we need to look this as more holistic as a water service. Although in US, these all created from with time in early 1800 water supply, wastewater, stormwater, waterways, water cycle. But in 21st century, we should look this as a one water concept or integrated water, whatever you term, so that it can be more integrated, homogeneous, and we can make a better decision on that. Water is kind of a three-dimensional. If you look at here, the natural water side is there, then the built system, and also the socioeconomic. Water is a very social, and in one of the workshop, we asked about who is the stakeholder. The answer came is everyone. Water touches kind of everyone. So that's kind of a complex environment. And then also if you bring in extreme events, then it becomes more complex problem to solve and the scale of that. So basically we are talking about this solving this one water, not with a political boundary of utilities, but looking at the basin scale. That brings the whole concept of a smart one water or intelligent water, whatever term we use in the industry. So our definition of a smart one water, don't pay too much attention to this figure. We got a lot of feedback in the workshop. We are going to modify this figure. But the purpose of this one showing is it's a complex system. If you're looking at the basin scale, our test bed is Delaware River Basin, first test bed. Then we have South Florida, second test bed. So we are going to work for 10 years in different test bed to implement this, the whole concept of a smart one water. And that's what NSF wants us to do. So looking into this as a whole, the data comes from many different silos. Each one has their own data for their own purpose they collect for that. But if we have to do at the system level, basin scale analysis, you need data at that scale. And then comes a lot of challenge with that trust issue, the fairness, biasness, the data quality. A lot of issues are there, how we do that. Because we cannot apply AI or any other analytic techniques if data is the core. Just like we say, if you don't get a good ingredient, you can't cook a food like Mexican food or Thai food. It's the same concept here. So this is what NSF ERC is. They are pillars, what they call. Convergent research is one, and let me tell you the concept of convergent research, they don't want to see only civil engineers or engineers coming and doing this work. They want us to look into economists, social scientists, everyone as a team. That's why it is a big team. So convergent research, innovation ecosystem is another which we need to focus, workforce development, stakeholder engagement, and then diversity and culture of inclusion throughout this center life and beyond, not just 10 years. They want to see after 10 years how this organization is going to survive. So that's kind of, and we held the workshop in each of these. So series of workshop, and some of you participated, a lot of you contributed. We have white paper in all of this. Some we are still trying to finish it, but all white paper will be uploaded on the website. On Monday, we held this workshop of workshop. That's what NSF wanted us to do. To now, we did one individual stakeholder workforce, but they wanted us to bring together all. So that's what on December 7th, we talked about all integration. You can't talk workforce development without talking innovation ecosystem, or when we are talking innovation ecosystem technology, not talking workforce, stakeholder engagement, governance implementation. So that's kind of an overview. We also talked about near term, mid-term, long-term, what's going on. And throughout this conference, it is organized in that way to talk what we will be doing in near term, which is 1 to 2 years, mid-term, 3 to 5 years, and long-term, 5 to 10 years, and beyond, how we are going to survive there. So these were the speakers for Monday, December 7th. As you can see here, we got pretty good feedback. A lot of people attended that. They provided us very rich. We had a breakout session. Then we organized this whole conference, which started on Tuesday, what we are calling it conference, swim conference. So workshop, we called it on Monday, and then the conference. So conference, we also organized, as you can see, I highlighted yellow. That's what we are going to cover today. But we have already covered Federal Initiative Organizational in the water sector. We heard from them yesterday, and then we had a panel sessions, governance, workforce, innovation. So we recorded all those. So we have a lot of now information going forward, how we can structure this and submit to NSF as a plan. So this was the speaker list from Tuesday. This was from the Wednesday. As you can see here, we have the top line of all the speakers. So we are on today, again, we have a star lineup. So we will start with the industry. We will hear from Arcadis, Xylem, Jacob, GHD, Microsoft, and Mueller. Then we will go into the panel discussion of stakeholder engagement, because that's very important. Who's the stakeholder? Who should be engaged at what time? These, we need to answer that today. So some will be right from the beginning. Some may come a little bit later. So who are there? Some may come after maturation, after graduation, what they call after 10 years maybe. So that's kind of a discussion we'll have. And then path forward, because we have to submit all these as a package to NSF. So some logistic, please be muted, only unmute. Chat function is really good. You can type all those and we pay attention, especially Kathy will keep reading the chat functions. Now, we have to thank our sponsor. You have heard from some of our sponsors. Today we will hear from Xylem and Mueller. First day we had Goagua, then GHD, Jacob. So we are really thankful to all our sponsors who helped us to run the show actually in a way. So contact is, I will stop giving the contact. If you are having any trouble, if you're logged out or you cannot log in, please, or you can't hear us or any kind of a logistic issues. And today in the evening, in the wrap up, I will tell you how you will, we will send you the link for all information, all presentations, all recording, because all the session, there's a lot of information we captured. So contact is very important. My email and cell phone, and then I have given Kathy also on cell phone. So either text or send us email. So I will stop here and hand over to James.
Sounds good. Thanks, Dr. Sinha. Everyone can hear me, correct?
Yes.
Terrific, great. Well, yeah, so I'm really excited for our session today, and thanks for everybody for joining. I always feel like, speaking on the last day of a conference is always, tough because it's, they're closing down the vendor session and everyone's leaving. And, this conference and workshop, I think is a lot different. And that's one thing I really do like about coming here. And, I think today we're just going to continue talking about that sort of journey on the One Water ecosystem, as I like to call it. And I think the important thing about an ecosystem is that, it takes all the different parts of the ecosystem for the ecosystem to actually survive and thrive. So I think, through this conference, we've heard about things from regulators and researchers, and then we've heard from utilities. So really today we're going to listen to consultant service providers this morning and hear where they kind of see smart water going and where they see the innovation happening and the future of that. And I'm always impressed by everyone's dedication and all the different groups and all the different pieces and parts that they bring here. So this session will really focus today on really the latest smart water tools, how research, regulation, and utilities are kind of driving, each of these vendors and firms like mine and the ones you're going to hear about today to really help develop new tools and approaches to support the industry, as we all work to provide better water, right? That's the whole point. None of us are really getting rich selling iPhones here. With each group, I think we hear brings new innovation and new points of focus. And we're really, advancing that science, I think, much more effectively coming together and doing these workshops. So thank you all for attending. The speakers are really looking forward to talking today, and I know we're going to hold questions until the end, but we're really looking forward to a lively discussion after the presentations. So today we're going to start with Jim Cooper. Jim, you probably heard speaking yesterday and moderating yesterday. He's the global lead for intelligent water at Arcadis. He's the chair of the Intelligent Water Infrastructure Committee at the Swim Center. He's also the vice chair of the AWWA Engineering Division and the co-chair of the Digital Twin Lifecycle Committee for Smart Water. And that's actually obviously near and dear to his heart because he's going to speak today about digital twins and how they're implemented and how you can implement them for your organization. So with that, I'll pass it to Jim.
Excellent. Thanks, James. Can you all see my screen and hear me?
Looks good.
Great. Okay. So yeah, appreciate the time to chat and just a very brief background, right, before I dive into the topic today. So Arcadis and Bluefield Research worked on really diving into the details of intelligent water over the past year and a half to 2 years. And there's a report that came out identifying, what is intelligent water? Why are utilities and companies across the globe implementing it? And then we dove into different types of intelligence. As you see, I'll be talking about collective intelligence. Now, fast forward to today, I'm here talking about how do you actually implement that, right? There's a lot of research out there identifying where the adoption rates are, right? If you can even just Google intelligent water and pull up some of the information that shows, along an innovation curve compared to the AWWA benchmarking results from the State of the Water Industry reports, et cetera. So really good information and really excited to dive in a bit on digital twins. It's one of the topics that is a bit broad, right? So certainly I'm providing my perspective on this, but there's many perspectives out there, and we'll probably hear some varying perspectives even through the presentations today. So let me dive right into it. I'll start very high level, right? What is a digital twin? And this is coming from the Gemini principles from the United Kingdom. And it's a realistic digital representation of something physical. Now, that's a very broad term and not specific to the water sector, but we can peel back the layers a little bit. And if you're all familiar with SWAN, the Smart Water Networks Forum, they have developed a digital twin architecture, gaining feedback from myself and many others, and probably many of you even on the call, looking at, well, what is a digital twin within the water sector, right? If we think about smart water, Smart One Water, right, what does this look like? And we'll get to how digital twins connect the Smart One Water in a few minutes. But as we see here, right, we have the physical system, and then you have the digital system. This presents them as very distinct and separate, but I think there's certainly some kind of gray area too, right? So we have things like physical sensors that certainly are physical, but there's a lot of digital aspects to them, data quality and data management. And so you have this transition between both physical and digital. But this is a great reference. If you're not familiar with it, it's available on the SWAN website. There's a number of subgroups that are working on many aspects of the architecture as well as other aspects of digital twins within water.
People said that they have these little pin-sized skinny flashlights.
I think someone might need to be muted.
Yeah.
So we peeled back the layers a little bit further and worked with just talking with various, like I said, various vendors and companies and utilities, and said, okay, well, what is digital twin in water? And this is a bit of a mouthful, but it's the definition we came up with. So let me just dissect it briefly. We see digital twins as a way of working using interoperative services in an enabling environment, right? So bringing in a bunch of different services and data streams in some sort of common environment that we can do something with. Well, what are we going to do with it? To understand, monitor, inform, optimize, or simulate an asset, system, process, or organization, right? So it could be something like a physical asset, or it could be something like a process or even an organization, right? And the scales of this are very broad. The UK is looking at creating a family of digital twins across the entire country. Whereas I was talking with a client and they were looking at creating a digital twin of every single customer in their system so they could forecast out what that customer is going to do from the water and wastewater, and not only from the rates and what their affordability capacity is, but also from their usage and long-term trends. So wide variability and scale here. From planning to inception and throughout a full life cycle of those assets, with the purpose of creating better insights and better decisions. I think there's a bit of kind of mixed opinions of this, but I think if you're performing something with a digital twin that can be done without a digital twin, I might not put it in the category of a digital twin, right? We want to make sure that, at least when I think of digital twins, you're achieving something you cannot otherwise achieve without it. So we wanted to try to identify and get a bit more tactical with what is and is not twins and what the capabilities are, right? So first we looked at various types of twins. So you could have a twin that might do something like asset health monitoring, right? Or a prediction or training, right? One of the common points of entry for digital twins within water utilities is operator training and what-if analyses. But you could also have things like security twins, right? Where you could have a distributed ledger or a blockchain technology that's a ongoing permanent record of the physical and digital systems access, their usage, their uptime and monitoring. So there's many applications here of types of twins. We then looked at various levels of twins. And you may be familiar with various levels of BIM. We're taking a similar concept with that, where level 0 is digital twin ready, all the way up through connected twins. And I want to just take a few minutes to briefly describe those various levels. So for level 0 digital twin, we consider this things like GIS or BIM or hydraulic model or SCADA. I've been asked many times, well, we have a SCADA system, right? Is that a digital twin? Well, we consider that a level 0 digital twin ready not truly a digital twin, but you're on the right path. And there's many different aspects of these specific components, right? A SCADA system has a very specific function, similar to a BIM or hydraulic model or even GIS, right? Pretty straightforward. If we go up one level to informational twins, it's a pretty big step to go from level 0 to level 1, because now we have some sort of interoperable environment. We have this platform that we can interact with that brings together these multiple data sources, pulls from historians, and this is really used for master planning, or it could be used as simply as a tool for providing data access. So many times when talking with utilities, one of the big issues is they just don't have access to the data that they're collecting. So this could be just a platform to allow them to gain access to that data and essentially remove the silos that probably exist in the physical world of their digital systems, and bring it all together so that they can access them. So you can do things like vertical asset management by combining BIM with CMMS, or horizontal with GIS and CMMS, for example. Obviously, you need to have some data governance and security protocols, and a bit of integration framework in place to do that. Level 2 is, again, a pretty significant step up in that it's similar to level 1, except we're bringing in live data streams, where level 1 could have been historical data, or data you're using on a previous year basis or something like that for planning, where level 2 are truly operational twins. Similar functionality, but we have a specific purpose, right? It could be operation support, it could be real-time analytics, decision support, right? There's many different applications of operational twins. Really just depends on that type of twin and their functional purposes. When you get to this level, you really need to make sure you have a data management plan across your utility, as well as a communication network plan. And then finally, we get to connected twins. And we see these as twins connected across domains, right? So we're taking very specific instances of level 2 twins, or maybe even level 1 twins, and combining them so they can interact, and you get the true value of having multiple utilities that are across a single geography work together. And so this is where I think of Smart One Water, right? Is where we have a digital twin of a water network, as well as a digital twin of the wastewater collection system and stormwater, and they can interact and communicate and coordinate together. And I think there's some really interesting things that can come out of having a truly connected twin that is a one water representation of a city or of a county, for example. So that's the various levels. I want to pause because I'm going to switch and talk about various types of intelligence. And whenever I do, I always get the question. I think it's well suited for the discussions later today. But the question is, well, is AI and robots just going to replace all our jobs, right? And I think that couldn't be further from the truth, right? The water sector is and will always be about people, right? All of us on the call, the operators that are out there working over Christmas and over holidays and all night long, right? And nothing, no new technology, no new automation, at least within the realm of what is available today, can just replace our people, right? However, if our people are using some of the latest technology, I think the value that they provide in a day, both to the utility and to the customers and end users, is significantly more than without that technology. So I just want to make that point clear as I talk about some of these technologies. So there's many different types of intelligence out there. I think we all hear of artificial intelligence, right? Natural intelligence. I define artificial intelligence as the ability of machines to sense, reason, engage, and learn in a manner that seems intelligent. Often the case, I hear companies or startups that might have a mild version of machine learning, and they're claiming to use artificial intelligence. I generally think that you need to have all of these components to truly have artificial intelligence, and that's even within the realm of narrow AI, which is where we are today. I equate calling machine learning artificial intelligence is going out and buying 4 brand new tires and saying you have a car, right? Certainly you have a good piece of the car, but you don't have a car unless you have all the other components. Whereas collective intelligence is the ability of humans and machines to collectively present far greater intelligence than they could on their own. And this is what we focus on within the water sector, and I'll explain a bit why. But first, this is not something that I came up with, Arcadis came up with, right? This is a well-researched topic. There's an entire center at MIT focused on collective intelligence, and they've done numerous experiments and really proven the difference between AI and CI. I see digital twins as really the ability to enable collective intelligence. If I think of a practical example, right, a cloud-based AI actually controlling and running a SCADA system to optimize a water treatment process, right? That could be AI. Whereas collective intelligence is that cloud-based AI looking at processing data in real time and providing recommendations for the operator to ultimately decide if they want to, for example, adjust a chemical dose or reduce a pumping rate within their treatment process and save so many dollars over their shift. You have that human in the loop as a part of the process to truly achieve collective intelligence. So we have a bit of a hierarchy, and I'm not going to spend too many details on this, but just know that you can start with the basics, tools and technologies, and then work your way up, right? You can apply computational methods, and then analytics techniques to learn and solve a specific problem, then ultimately achieve artificial intelligence and collective intelligence. So I think of AI as technology and automation, or I think of CI as really the people and integration of that technology. So back to digital twins. Why am I talking about digital twins? I mentioned research that we've done over the past couple of years with our Demystifying Intelligent Water report, talked about why utilities are adopting intelligent water and where they are in that journey. The recent State of the Water Industry report, we took a look at that and said, can we identify why and how digital twins support your greatest needs? So what you see here on the screen are the top 10 issues facing the water industry. And those are largely unchanged over the past number of years. We're seeing emergency preparedness jump up a bit, but certainly the top ones are pretty much the same. Some interesting data as well from this report that I think is worth mentioning, particularly with this group. You can see the table on the top right is looked at essentially the asset management planning based on the utility size, right? So even with very large utilities, only 40% of them have implemented asset management, which is pretty much surprising to me. I think the large utilities, all of them should be. Now, a large majority have implementation in progress, but you can see there's a number of utilities out there that responded to the survey that do not implement asset management planning. Now, if we look at the graph on the bottom right, and again, these are both from that State of the Water Industry report, the data kind of aligns, right? The majority of spending, at least for capital spending, is on replacing and upgrading existing infrastructure with a very small percentage on technology. Now, imagine if we could just increase that technology spend a little bit, how much reduction in replacing and upgrading infrastructure we could achieve by doing that smarter and more intelligent than we could without the planning. So digital twins, we've, like I said, looked at various types and twins and aligned them with the State of the Water Industry report on the top issues, and there's significant benefits that can be achieved with these. I'm not going to go through all of the details for sake of time, but happy to discuss those further, particularly in the Q&A. So I'll just close with an example. So this is one example where we had a number of PFAS treatment units. Arcadis has over 100 different locations of PFAS treatment units, and really wanted the ability to remotely view those facilities and get a live pulse on the trends without having an operator there present, right? So we integrated various sensors throughout the design, built a common user environment, right, and enable real-time monitoring. So you can actually go in and look and see if a valve is turned on or off, and identify any of those changes that are needed to be made, and it resulted in a pretty significant O&M cost savings as a result of that. So with that, I thank you for your time, and I'll turn it back over to James.
Great, perfect. Thanks, Jim. That was really innovative there. I like the last slide there. Next speaker is Dr. Lindsay Burt. She's a client solution manager with Xylem Digital Solutions. She has extensive experience in water resource engineering, including digital intelligence in water and wastewater networks, water quality monitoring, and sustainable design. She has her PhD in agriculture and biology from Purdue University, and also did her undergraduate work at Texas A&M. And today she's going to be speaking about One Water innovation and its opportunities and the inhibitors to adopting them. That, Dr. Burt, ready to present there? There we go. We're seeing your screen now. Not hearing you though, so make sure you're unmuted there. Lindsay, there we go. Now you're unmuted.
Yeah.
Perfect.
And then if not, maybe if you can share the screen for me. Do you have the slides? Let's see.
Do you want me to slide? I can, if you need to, I can share them.
Yeah, that would be great. Sorry about that. Something
No
just
worries.
happened.
Let's see, I'll bring it up here.
So while James does that, again, I just want to thank everyone. I'm actually going to turn my camera on to say hi to everyone, and thank you, Dr. Sunil, and also Kathy, as well as James, for just inviting me to present among the esteemed group of panelists. And exciting to hear also from Jim Cooper a little bit more on digital twins. When we talk about this digital intelligence, it's really centered on leveraging the power of data through sensors and real-time monitoring, data analytics, and system modeling to inform better system-level decisions today, while planning future outcomes for operations, maintenance, capital planning, and really just better understanding the performance of existing assets. Utilities are empowered to focus their limited resources in the areas that need it most. And so before I go on to the actual presentation, for many of us attending the conference today, and I was able to hear some of the presenters yesterday as well, it seems that we've been talking about smart One Water ecosystem and digital intelligence for a while. And just kind of reflecting, because we're ending this year, this is December, and if anyone doubted the need for digital transformation before, I would say, 2020 and this unprecedented year has created the environment that makes this transformation a reality, right? The speed at which water and wastewater organizations across the globe have had to react to this pandemic, economic pandemic, social unrest, has made evident that technology use may not just be optional, and really, very importantly, that good, actionable data is one of the most important allies a utility, as well as any other organization looking at smart water, have to navigate these current challenges and current uncertainties. So I'm going to talk a little bit about this One Water digital innovation and some of the opportunities and inhibitors. We go to the next slide. And so, in the next slide, Jim.
Yeah, I'm working on it. Hang on.
Sorry, James. Oh, perfect.
No worries. There we go. And get the right control.
And I think you'll have to click twice. So as a result, many, and you can click again, as a result, many water and wastewater organizations, they are having to do more, meaning increasing demands are related to demographics, regulatory compliance, the external environment. We're seeing that wastewater and water organizations are having to do this with less money, and demonstrating abilities to improve cash flow and affordability, and as well as being safe, right? Safe for our teams, keeping teams safer wherever they are is critical. And so with digital solutions as our core at Xylem, we serve as a trusted advisor to senior leaders, enabling data-led decisions to drive operational outcomes at significantly lower costs and safer for their teams. And we think about digital intelligence approach as having really 3 layers, as you see in the right. First is just sense. Sense is around making sure that you have the right data flowing into the system. It's this sensing layer where you're pulling in ones and zeros, but it's really telling you something about your asset. And I think I agree with Jim. It's kind of shocking to see that only 40% value are doing asset management at a full scale. So, being able to deploy this first tier of sensor deployment is really critical. The next layer is predict. It is around understanding and modeling, interpreting the results of information. So this is really that analytics layer that we heard Jim touch upon with, digital twins. And then the third layer is what I call ACT. ACT is around developing decisions, recommendations, and actions based on the results of the model. And so, coupled together, integrating this 3-tier approach of sense, predict, act is really where this decision intelligence is being integrated in our water and wastewater utilities. And in some cases, utilities don't have, the data available in their existing assets. And so sometimes there's opportunities to put soft sensors. Sometimes there's opportunities, as we heard, to enhance your digital twin analysis. But it's really the core of this is being able to make better informed decisions. And so a couple aspects I wanted to focus on is looking at, focusing on operational resiliency. Oftentimes when we're thinking about digital intelligence, we're kind of looking at the technology side, but what about safely assuring operational continuity? We are seeing in this unprecedented times, maintaining 24/7 control during remote working is essential, and reducing the risk of downtime and call outs, as well as repairing, replacing, and bypassing problematic equipment and infrastructure. How can digital intelligence help to be smart at maintenance and repairs rather than a rotational basis of doing maybe pipe repairs, using the decision intelligence platforms to make better informed decisions on maintenance repair. And then also, one other thing to consider as we're discussing about the Smart One Water is really being able to demonstrate financial resiliency, as I show on the next slide. When we're talking about that, safely increasing utility cash flow, being able to demonstrate reducing energy consumption and of third-party costs as well, and how we can deploy decision intelligence to optimize capital spend by renewing rather than always replacing assets, and utilizing decision intelligence to shrink capital improvement plans safely, I think is really critical. So, when we look at this a little bit more, Xylem has strengthened our digital capabilities over the past years by adding technology to our portfolio and expertise to our teams. And this means that whenever we work with our customers on finding answers to their questions, we always look at data as another asset that we can use to gain insights that can help them achieve their goals and maximize their expected outcomes. And so oftentimes we do take this intelligent watershed management approach, this 3-tier approach of turning on the lights, as I mentioned, adding sensors and understanding what's comprehensively going on within the wastewater network or water quality or even a wastewater treatment process. And then, again, creating that digital twin, looking at cognitive hydraulic models, running real-time simulations, and looking at comparing and contrasting this model simulations to sensor data. And then again, operating that network, co-designing dashboards, I think is critical. When we talk to a lot of wastewater operators, is just as you mentioned, we can't take the people out of water, right? And so working together, having a glass box approach, co-designing dashboards and visual interfaces is critical as you operate the network to empower operations using real-time decision support. And so again, this, three-tier approach is helping to save, achieve ROI for our customers over the millions, and it's helping to reduce combined sewer overflows by allowing them the ability to maximize the capacity of wastewater networks rather than building new infrastructure. So I just want to highlight a couple examples in the next two slides. One of them is just, talking about asset management. There was a city in the United States that had been operating an aggressive cast iron pipe program, but the breakaway rate was no longer decreasing, and they needed a way to analyze their system to reduce pipe breaks further without increasing CIP. And so one of our digital solutions platforms, RiskView, helped the utility reduce the risk of system failures by making data-driven informed recommendations on an asset reliability and pipeline prioritization. This helped to achieve 80% of reduction in capital costs and also a projected 60% reduction in pipe breakage. Another one I wanted to point out is another example of just, wet weather resiliency. This is one of a great example in upstate New York, where a city was built for a larger population that it serves today. And by leveraging infrastructure capacity they have in their sewer network, they can better manage their sewer overflows. And so the city had already been able to shave off a couple $100 million off the cost to comply with their long-term control plan and eliminate sewer overflows. And all this was done by developing a digital twin of their wastewater network that enabled, real-time optimization to make better use of their existing assets that they already had in their system. And if you know the assets that you have and what conditions they're in at any given time, you're really actually able to develop and control and develop rehabilitation strategies that are smart, that allow you to do more than what you've ever done before. And really, you don't have to reach those capital dollars to build solutions to problems that may already be within your grasp. And another example is also in Germany, looking at deploying decision intelligence within a wastewater treatment for energy optimization. And so this client, they really wanted to reduce their energy consumption from 5 parallel biological tanks, but at the same time comply with legal effluent concentrations. And so what we did is we built models of carbon and nitrogen and phosphorus elimination process to create an optimization strategy. Again, co-designing that dashboard with our client, our partners, and continuously calculating the best set points for the aeration in each zone. And as a result, we found a 25% reduction in their specific energy usage, which is really a gain. And also I wanted to point out with this example too, that there was a lack of actual live sensors. So we worked on the estimation of load coming into the plant. So we developed these virtual analyzers, as you say, or soft sensors, to be able to use with the neural network modeling to estimate incoming carbon and nitrogen and phosphorus. So again, looking at inhibitors, there's several inhibitors. I think about workflow. This pandemic has revealed that we need ever more workforce augmentation, but not everyone will be working remotely. So, what will that look like? How these dynamic changes in human resources and remote operation impact utilities and other organizations as they deploy a smart water ecosystem? Security. I mean, implementation of secure digital technologies has proven to be a real differentiator between resilient and adaptive utilities. And so it's critical to be able to pinpoint, the security workflow process that will be taken when you're integrating digital intelligence. Then interoperability, oftentimes data systems are in silos. And so, the question is, how do we integrate these data sets? How do we integrate these data sets with even one utility? And also, too, how do we make it useful? How are we making sure we're still answering the questions that we're trying to solve? And then again, market failures. Will any future market failures or variabilities result in a need for demand side management, which aims to improve the provisions of existing water supplies or before any new water supplies are developed? And the complexity of physics, and we're really looking at, I think Dr. Sunil said, at a basin-wide scale, right? So there's going to be a lot of complexity and variability in physics, and how do we take that into account in our decision intelligence platforms? And then I had a question mark, because I was just thinking about, being among an esteemed group of panelists and just hearing from you all, what are also inhibitors? I think about, what about considering fail-safe mechanisms? Fail-safe mechanisms incorporating the design to prevent property damage or risk of human life is critical. I haven't heard much about affordability. Water prioritized should never be unaffordable. And so, developing decision intelligence tools that take into account of communities' affordability, not only in short term, but long term, is critical. And then funding. When we're talking about the stakeholders, the multiple stakeholders, what about lower economic disadvantaged communities? How are they going to afford digital intelligence? What about farm fields, farm owners and landowners? How do we deploy digital intelligence in a way that's affordable to these end users? And then empowering communities. I haven't heard this much yet, but what is our role in how we're going to incorporate citizen scientists in our digital or smart water, One Water platform? We're seeing it all around us. Citizen scientists are actually contributing data. And so how can we incorporate this into these platforms as well? And so with that, I would say, there is a silver lining in this year, this unprecedented year, as we're responding to these crises, and there contains these seeds of a need of digital transformation. Not only that will help utilities, but broader organizations in the smart One Water to do things faster, cheaper, safer, and also to be more resilient for any future shocks. So I thank you for your time. Look forward to being part of the panelists.
Great. Thank you, Lindsay. Quickly escape out of that. Great. So our next speaker is Dr. Raja Kidiyala. He's a vice president and senior technology fellow at Jacobs. Also did his undergraduate at Purdue and is a doctorate from my alma mater, which is UC Berkeley out in California. And he's here today to discuss digital transformation, what it is, factors affecting its adoption, and examples of it in the smart water ecosphere. And with that.
Excellent, thanks. And always great to follow a fellow Boilermaker. Wanted to thank Dr. Sinha and the great team there with the Smart One conference for allowing us to present some of our ideas in terms of digital transformation and how they can actually be applied across the entire asset life cycle. So first, defining what is digital transformation. Fundamentally, it's the process of exploiting digital technologies and the supporting capabilities to create a robust new business or operating model. A lot of times we focus on the shiny objects, the cool things, the technology, and in all honesty, it's not about the technology, it's about the outcomes. What can we do to really digitally enable business transformation? So when you think about that digital transformation, it's not about the technology. So why all the hype about transformation? There's a fair amount of research out there in terms of the beliefs for digital transformation, providing that competitive advantage, the level of that competitive advantage, and then also the time frame of when you really need to apply that transformation. But there are also some negatives out there. 70% of digital transformation efforts actually fail. And if you take a look at the failure elements of it, it's lack of upfront commitment, failure to take an iterative or sprint approach. So getting out there and deploying things quickly and getting results and learning from those results, as opposed to more of a monolithic approach where you get in there and get the technology and you wait a long time and And by the time it is fully implemented, the environment has changed. Obviously, 2020 has really led to a change in a lot of environments that we could not have predicted. So aligning to some of that fast pace components are very important. Lastly, the last element of failure, putting technology first. It really needs to be about the business or operational outcomes that you're looking to achieve. So when we think about some of the digital disruptors out there, we've gone and surveyed the market. These are the majority of responses coming back. Roughly 60% felt, hey, artificial intelligence is a digital disruptor out there. AR, VR, the utilization of drones for inspection, the Internet of Things, and then process and workflow automation. You know, these are some of the technologies that people do focus on. But again, you need to really be careful about leading with the technology. You know, another metric, 9 out of 10 AI efforts that people are working on do not actually make it into production. That equates to 90% of the time spent by your data analytics team not really doing anything in terms of moving the needle. So you really need to think about the underlying business processes, the people side of the fence. It isn't all just about technology. You need to have balance across all three. If you want to have stickiness in your transformation efforts, you need to engage with your people, get endorsement on the people side. Implementing technology without rethinking or rebooting your processes is really going to lead to a suboptimal solution. So one thing that we see a lot in utilities when you start talking about implementing some of these digital solutions is the need for upskilling of your resources. Let's be honest. I mean, there's some advanced digital skills within utilities, but it's typically held by a very small minority. And when you think about the learning curriculum or the training curriculum that you put in place, it really does need to be personalized. So we've been working with a lot of utilities to push what we call persona-based content. So, you know, a young engineer that's coming in from a good university is going to have totally different digital capabilities versus somebody that's been in the organization for a number of years and is not as adept at some of those things. So tailoring the training curriculum so you can actually have your folks properly get upskilled is very important. And this kind of persona-based concept really works well. We also studied digital stickiness across the entire asset lifecycle. And if you take a look at the different elements of an asset lifecycle from planning, design, construction, O&M, into decommissioning, it's interesting. We're 25% lower in terms of digital adoption during that O&M phase. We're pretty gosh darn good during planning and design. So that's where we have the 25% higher. But we aren't nearly as good during O&M. What can we do to get better digital adoption during that portion of the asset lifecycle? Other thing that we're seeing is data flow across that lifecycle is currently suboptimal. Feeding forward from planning, design into construction into O&M, we are definitely missing digital assets that we could be pushing across that entire asset lifecycle. Other thing that we're not good at is capturing performance information that can then feed back into the next iteration of that asset, back into the future planning and the future design. You know, Lindsay talked about how the pandemic has driven this resilience theme. We're definitely seeing that as well. Business continuity, operational continuity, and cyber protection are really key things that we're seeing out there that the pandemic has kind of shined a light on. But we don't see that going away going forward, even after we get into recovery. So we talked about that asset life cycle. If you take a look at the asset spend across that entire asset life cycle, You know, upwards of 80% can actually be spent during that O&M phase. And reflect back, we just talked about digital adoption and digital penetration being 25% lower during that O&M portion of the asset life cycle. The other thing is the large majority of the time spent for an asset is during that O&M side of the fence. So what can we do to get better digital adoption? There are certainly digital refresh cycles that happen outside of the asset refresh cycles. So it's interesting to note that that time cycle for those digital refresh cycles can be more in the 5 to 7 year time frame versus the lifespan of an asset being, you know, upwards of 50 years. So what can we do to really create that digital thread that flows through that entire life cycle? Let me walk through an example. We're currently working with Singapore PUB at their Tuas water reclamation plant. This is a 200 million gallon a day treatment facility that actually won the 2019 Year in Infrastructure Award in the water sector. So this was a full digital design from the planning side of the fence, from the design, then into construction. We actually had that digital replica, creating that digital asset that we could then leverage downstream. So having that asset, that digital artifact there up front allowed us then to flow into the tendering process. So we actually had a virtual model-based tendering effort where the contractors could come in, take a look and understand exactly what they had to construct. Yeah, sure, we had their tender documents and they fully understand that, but you know, taking a look at a volume of a tender document versus virtually interacting with what they actually had to construct really allowed them to better hone their cost and understanding and scheduling of that actual construction effort. That then flowed into the actual construction where we could take a look at where the actual construction was versus our plan. We could understand where there was divergence and begin to put in remediation efforts to get them back onto schedule. Again, having that digital artifact up front allowed us to flow into construction and then flow into O&M as well. So utilizing a digital twin, we're taking that digital replica, that digital model, fusing it with actual real-time data to then forecast performance information for that facility so their operators could be understanding, looking forward, what is going to be happening based on their current operating conditions and control, and adjust so they can actually work out better treatment regimes. Another example is down for at Tarrant Regional Water District. So this is feeding a main transmission system that's feeding 2.1 million residents. We needed to optimize over 300 miles of pipeline that's moving 350 million gallons a day. The yearly operating cost of moving that much water was in the range of $10 to $30 million a year. So a fairly power intensive infrastructure project. So what we ended up doing is applying that digital thread across the entire asset lifecycle through a digital twin, from planning, design, operational analysis, and into operations as well. So utilizing our replica platform, we were actually able to verify the pump selection for a wide range of conditions. So before we actually even got into constructing it, during that design phase, we could understand exactly all the components that needed to get sized and implemented and where we should put those assets. Development and testing of the actual control logic that was running that very complex system was able to be done in the digital realm before we actually got done in terms of the construction completion. We utilized a multi-criteria analysis with constrained optimization to then drive that operational efficiency. and understanding how we could actually minimize the energy cost. So the end outcomes for this system is we fundamentally transformed their transmission operations. That digital thread from planning, design to operations drove that adoption. We had a validated design and software that reduced the system tuning and startup. They actually had a 100-ton gate valve, the largest in the world. That was a major component in that. Us understanding how we could tune and operate that in the digital realm before we actually applied it in the physical system really was a huge benefit. Lastly, if you take a look at the entire asset lifecycle for that, we're projecting a savings of $50 million across that asset lifespan. So again, being able to have those digital assets and digital artifacts up front, have that flow through each individual portion of the life cycle, really ended up driving that value creation. So in summary, digital transformation is really more about the people side of the fence and the process side of the fence, and less about the technology. Don't focus on that shiny object. Upskilling of staff really will be necessary, and having that persona-based training to provide that focused element in their learning process is key. Developing digital artifacts that can be utilized throughout that entire asset lifecycle, and not really siloing across the different stages of the life cycle. Don't look at just planning by itself and design by itself. There is flow across that you can generate value from. Thanks.
Thank you, Raja. That's impressive stuff. So we're doing well on time. I think we've had some excellent speakers so far. I also want to put in a plug for questions. So as we get closer to the end, we've got three more speakers here. So as you've got questions, please put them in the chat. Think about them, and if you put them in the chat, I'll go ahead and have them ready for the speakers when we get to the end. But our fourth speaker is Shashank Ramanan. He is a global leader for digital water at GHD, and he's here today to talk to us about the digitally enabled integrated water management. What is it? What are the building blocks of it, and some case studies that where it has been effectively applied. So Shashank, are you ready to go? There you go. All right, take it away.
Yep. Can you hear me? Awesome. Thank you. Yep. So first of all, I just wanted to thank Dr. Sunil Sinha and yourself, James, in terms of providing us the opportunity of making this presentation. I'm just turning my. I'm not sure if I've turned my video on as well, so just give me a second. Okay. Yep, I think I'm here. So, yeah, thank you. So, yeah, like I said, I've heard the conference notes that were done yesterday and today as well, and it's a hard act to follow after Dr. Raja, commenting on digital. So, but I will try to do my best. I think a few key points that I've made a note of is the ecosystem, digital twins, blockchain, all of these technologies. So I've been about 19 years of experience in the pure technology industry, and I think we rely on our buzzwords quite a bit in the IT industry, and it's important that we demystify digital and we get the right perspective of what digital can help the water industry on, and that's going to be the endeavor in my presentation. So I'm presenting on digitally enabled integrated water management. That's something that my colleague Anne Lynch presented on IWM yesterday. I'm just carrying it on with a digital flavor. Now, when I talk about digital and digital helping to solve real-time problems, as a kid, I was completely obsessed with the hare and tortoise example. And I was never able to understand why the tortoise won. I always wanted to enable the hare to win, from a perspective. And then I realized that the tortoise was slow and steady in the race, and et cetera, and the hare had a nap, et cetera, et cetera. So from a digital perspective, if we examine this example, and if I was employed as a consultant from GHT as a digital consultant, the way I would look at this would be a route mapping algorithm, a distance versus time graph, and help the hare to have his nap and still make it through and reach his destination. So, making digital practical, making digital um, more towards solving problems in water is our endeavor from a digital perspective. I've heard terms like blockchain, digital twins, and all of these exciting terms, but really, what does this mean, and how do we apply that um, to pure real life water related solutions is what my endeavor is in this presentation. So GHT, the organization that I belong to, we've had about 90 plus years in operation. We have close to about 10,000 people, 50 plus service lines. We primarily function in 5 different segments: energy, resources, transportation, water, property, and buildings. And now we also have a segment around obviously buildings and properties, but we also are delving into future energy as well in terms of an overall segment perspective. Now, coming back to the overall water sector, there's today and there's tomorrow, right? In terms of a future. And there are significant problems that we face from a water perspective, from a water industry perspective. There's water security, population growth, flooding. How do we map all of this out? What's our investment in terms of rehabilitation of existing infrastructure, whether it be linear or in perspective? I did hear that there was also the point about skilling of the workforce and all of that, great stuff. And how do we help, or how do we get digital to enable all of this to happen? And obviously, there is something which is there in the climate change perspective as well that we have to look at. Having said that, my colleague yesterday did present the integrated water management framework that we have. There are drivers from an IWM perspective, like, for example, aging assets, economic conditions, deep uncertainty, flooding, water security. There are services that are provided by the industry. There is a collaboration, and there are systems and processes as well. But what's important to note here is that the future is uncertain right now. When we look at all of this, right, the way I look at digital is, how do I make the next 600 days of my water utility more predictive? How do I empower the water utility to be more predictive in their future and to make their future more certain than uncertain? And that's where I think digital can play a big role. Let's forget the terms of digital twin and blockchain and all of these technology, great terms that are there. But how do we make that realistically happen? And there are certain examples that I will provide that we have done this by, because when I have approached a lot of our clients, and when we've discussed on water utilities, unfortunately we find that from a technology perspective we are on a different plane and the client is on a different plane. So it's important that we demystify what we are doing from a digital perspective. And I actually love using this slide, because when I present this to most of the water utilities, it's a kind of an aha moment, because nobody has seen this broad diagram in terms of what digital can do across the entire spectrum. This could be applied to a water treatment facility. This could be applied to a wastewater treatment facility. But there is a digital play in each one of the water journey. So whether it be ecosystem monitoring, we all do water quality monitoring, but we can also do remote water quality monitoring through sensors, through IoT. There is also surveys and vegetative water mapping that can be provided. There's GIS data there. When you get into water treatment, there is SCADA, automation, all of that services that, from a digital perspective can be offered. Then when we get into the water network, leak detection, distribution, predicting main breaks, failures, those are important components that digital as a solution can give. From a customer perspective, there is metering, billing, stormwater management. How do we avoid, the overall stormwater flows, etc. Wastewater networking, we are finding quite a bit that odor is becoming a problem in wastewater networks for communities. So how do we do remote odor monitoring? How do we do gas emissions around wastewater treatment plants? Sewer overflows, right? I think somebody spoke about combined sewer overflows and analytic present on that. But that's a great digital play as well there. And then obviously you have the wastewater treatment process in terms of energy optimization and solutions around that. And then the reuse part of it, right? So how do we monitor turbidity at the discharge? How do we do all of that great stuff so that we ensure that the right treated water is put back into the reservoir or put back into the river from which we are extracting the entire water on? But the interesting part is that when you look at the slide holistically, right, from a solution map perspective, you recognize that, the conversations depends, right? As a city director, you will recognize that, oh, okay, I can possibly get all of this integrated into one single screen. Or if you're only a water treatment perspective, you will realize that, okay, I can get my ecosystem and water treatment perspective into a single screen. Or if you're a wastewater treatment operator or a wastewater treatment plant manager, I can get the right-hand side of this slide into a single screen. The importance is to recognize that from a digital perspective and a technology perspective, like we helped the hair win in terms of the first slide that I presented, we can give an overall view of all of your treatment facilities into a single screen. And that's important to note because you have decision at your fingertips. And that's where we define the role of digital in water. But if we have to build this, then it's important to understand that there are a few building blocks that we need to get in place. And this is not my slide, this is an ISA 95 levels of automation slide. We often confuse different terms together from a digital perspective. We confuse digitization with digital transformation, and we use these terms quite interdependently and quite wrongly in the industry. But just providing a definition here. So when we look at the levels of automation, digitization is primarily level 1 and level 2. And I don't want to cover this slide in more detail, but if we have PLCs, DCS, devices, equipment, sensors, controls, SCADA, we're still in the digitization part of it. When we include EAM systems in the plant, CMMS systems, maintenance management, and we integrate that, we are in the level 3 part of it, which is digitalization. And then if we truly want to look at digital transformation, right, that's where the technology build comes in. So, water utilities may have an ERP system, may have financial systems, but none of those systems get integrated. So let me give you an example. There is chemicals in a water utility, but the problem is that the amount of chemicals is regulated by one particular system. The order and inventory of those chemicals is regulated by another system. The financial metrics of ordering that is regulated by a third system. So if we were able to integrate all of these systems together, you would be at level 4 in terms of your network. And that would be a true digital transformation where you know exactly when to order what chemicals in the water treatment plant or a wastewater treatment plant. So these are some examples and a way for building the journey towards digital transformation that I think we are all seeking from this presentation. So some examples on what we've done, a large water utility on the West Coast. It's a very interesting example that I'm passionate about. There were 11 different water sources, and we developed an analytics model on the cloud, integrating 11 different, plants, SCADA systems, sources, etc., to be able to decide which water source is the right water source to use at the right point in time. This obviously involves cybersecurity. This involves a security protocol. A lot of due diligence was done. But this is an example of how we put that overall model to work, how we make digital actionable. And again, we could classify this as a digital twin. We could classify this as various other terms. But I'm just, this is a practical example of how decision forecasting helped a utility. A second example is in terms of combined sewer overflows that we implemented for Unity Water. We now have a real-time monitoring perspective that comes in terms of the prediction model, the actual overflow, and running an artificial neural network algorithm at the back end. And I'm sorry that I used the term ENN. I didn't want to use that, but the fact is that we can now use algorithms practically to predict sewer overflows. And we've done that, and the benefit of that, according to the client, is simply that, he can send the right amount of crews with the right person at the right time to a particular spot where there is a projected sewer overflow. So that's a practical benefit for the client. Water main break analysis, again, we implemented a model around, again, a neural network algorithm and analytics with the amount of data that we collected to be able to implement this for Hunter Water. So again, if you look at this entire matrix, right, from the overall solution map, what are we getting at the end of the day? We are getting a lot of data. And how do we make this data actionable? How do we get this data to work for us? And these are some of the practical examples that I'm presenting here. So for Hunter Water, for example, we were able to solve their main break problem using all of the data that we got. So these were some examples that I wanted to give you in terms of how do we make digital practical? How do we make digital actionable without, I love my buzzwords. So, but the problem is that we need to make this actionable for the people we are speaking to. So when I speak to an operator and I tell them about digital twin, it just doesn't make sense. So I would want to explain it in this fashion so that he or she can recognize that what digital means to them. Finally, a summary on the digital roadmap for water. So this is something that, again, I've spoken to a lot of water utilities on. And I'll be the first to admit, as a technology professional, I would go with this slide from left to right. I would look at harvesting data, turning data into information, and turning information into action and getting optimized. But guess what? My recommendation to all the water utilities is look at this slide from right to left. Understand what the business problems are. What are you trying to solve for? Is it a chemical inventory problem? Is it an energy management, is it an energy optimization problem? Is it a process optimization problem? And based on that, there are different algorithms and analytics that we can give from a digital perspective that can help you. The next step would be that how do you want to visualize that data? What's the right way of visualizing? Is there, do you want to, the ease of visualization, mobile, desktop, etc., is also, a key part of it. And then finally, are we selecting the right amount of data? Do we have the right kind of data to be able to deliver on the third result? Unfortunately, as technology professionals, we look at this graph from left to right. But my recommendation is, as water utilities, let's look at this graph from right to left. What is it that you want to achieve? And based on that, everything else can be constructed. So with that, that completes my presentation, James. Thank you.
Great, thank you, Shashank. That was excellent. I think what we're hearing is that, yeah, the right to left trend is something that's been in a couple different presentations. So I think that's a good key takeaway for everybody to and think about as we move forward. So our next speaker is Jovita Nassal. He's with Microsoft. He's a researcher in Internet of Things and IoT and artificial intelligence. And he is going to present hopefully today. There he is. Great. You got your.
I'm here.
Great. You got your presentation there, Jovita. I think good. There we go.
All right.
Just
Give me
about
a
to see you.
second here. Let me bring my presentation up. Just bear with me 1 second. So how is everyone doing today?
I think we're good. And a good morning.
Let me know if you can see my screen.
Not quite yet.
Share. All right.
That appears to be coming in. There
Is that
we go.
good?
Now we've got it. Go ahead.
All right. Good morning. Good afternoon, everyone, depending on your time zone. My name is Jovita So, and I am with Microsoft. I've listened in and out, to great content here today. So some of what I'm about to say may be repetitive. The speakers have been awesome, and they've touched on key themes that you'll probably hear me talk to some of those, right? We just heard about the problems that we face as it relates to water. I won't let you read all of this in the interest of time, but the main thing is that we cannot have life without water, right? If you look on the left-hand side, you see the same area of that location that is dry and totally arid, and on the right-hand side, that is that same location several years ago. It's lost all its water. And then some of our habits also are contributing to the problem, right? It is alleged that it takes about 30 gallons of water to make a glass of wine, or 13 gallons of water to make a gallon of food, right? And then in the US, an average American consume about 80 to 100 gallons of water a day. So with all these problems, you've seen in the previous speaker talked about population growth, and then with all these inefficiencies, the problems just keep mounting. Those challenges are there, we've learned about them. So I'm going to skip the challenges, they are well known. This slide breaks down some of the industries that are contributing to this problem more than others. You will see that oil and gas is at the top of that, hotels and some of our leisure and industry people are also at the peak of industries that are contributing to this factor, right? And then, but then I want to focus more on the things that we can do, and it's not really going to be much dramatically different from what I've heard from a lot of you great speakers. So I'll jump right into it. One of the themes that we hear about is this thing called agri-banking, which is a way of solving some of the problems of water in the agri-industry. It is really to reuse water that is being spent, right? And there are techniques to do that. You recycle the water, you reuse it in agriculture over and over again. And as we've seen in that previous slide, the agriculture industry is one of the top consumers of water. It's necessary. We need food to live, but we also need water. So how do you balance those two conflicting needs? From an organizational and enterprise standpoint, I don't know if any of you here was in the presentation yesterday where I talked about the benefits dependency network, how you can start by looking at the business drivers and then work your way back to the solution instead of starting from the solution and try to justify it. Today, I want to talk more about strategy, which is where you start from assessing your risk. We've already done that quite a lot here. In many power and utility industry, you will see a lot of redundancies. There is quality issues. The supply chain is in many cases antiquated and needs improvement. Really, how we think about these things, whether it's water as a durable asset, that not many people think of water as an asset today, or as a product, right? There is a slide here, I don't know which one, which says that in the last century, most of the wars were fought over oil, but in the next century or this century, most of the wars may be fought over water. We've talked about management. A good case study is Israel, which went from really struggling with water to becoming a top case study in water management. And if you look at that today, their water reuse is 86%, which is fantastic because they don't have enough water out there in the Middle East. And if you have to figure out ways of recycling and reusing water. So smart water management is crucial in all of this. This is actually a solution that we work with some of our partners to implement in Kenya, in sub-Saharan Africa, where they pretty much picked up at around 55% of water access in the country. So pretty much 45% of people do not have water. And we went in and we worked with some of our partners to try to solve this problem. The key drivers, I've seen a lot of the speakers touch on these topics, so I won't focus on this. And this slide was actually in my presentation yesterday also. Robotics is a big, part of this. I agree with the last speaker about things like blockchain not being, they sound really cool, but you want to focus more on the things that will bring immediate impact. Right, so I'll leave these options for you guys to look at the key themes. This is from the World Economic Forum. Now, and I also talked about this yesterday. The main point about this slide is the fact that innovation is moving at a rapid pace, and the water industry has not really kept pace with innovation. When you think of the Earth, some 4 billion years ago, 4.5 billion years ago, innovation was very, very slow. But as we enter what we call the Cambrian acceleration, you start seeing that things were moving a little bit faster. Today, we are in what I call AI acceleration. And what that means is that we've shortened the time to solutions quite dramatically. And how we do that depends on some of the behaviors that I've actually heard. I believe that the last two speakers touched on this quite eloquently, how we could approach innovation in the utility industry and move ourselves forward. Today, the key themes or drivers is that people talk about is really data. Data is becoming that new oil. As you know, they used to talk of oil as gold in the last century. Today, data is gold, right? The water industry generates ton and ton of data, but you want to harness the power of that data in order to drive innovation or derive innovation, insights into the data and use that to drive innovation or intelligence. And you would do that not necessarily on-prem, but the cloud is going to be the new control plane for that to happen, right? It is a challenge because most of the water industry, the environment that we operate in the water industry, are in the OT environment, the operations technology environment. And exposing that to the cloud is also a challenge. So what are the cybersecurity ramifications of something like that? So we are caught between this, at the fork of this road, where we want to get the benefits of the cloud and all the intelligence that it produces, but also we want to do so in a secure way. And we want to figure out how to do that securely. That is really the call to action. How do we securely move to the cloud? What is this diagram? This is courtesy of Schneider Electric. We work with them, or Schneider Electric. We work with them on a solution. As you can see here, the main point of this is digital twinning. And I did hear also someone talked about that, which is really crucial when it comes to predictive maintenance, especially in an industry like ours where most of the assets are buried on the ground, right? You can't really access a pipe easily. So in order to see how a valve is functioning or or some kind of an actuator is failing, you want to bring in some intelligence and sensors and call it shared reality or AI, AR solutions are going to be critical for something like that, whether it's for predictive maintenance or analytics. We're going to need that, right? I'm amazed by the solutions that you see in some of our partners. Microsoft, I work for Microsoft. We don't really have any hardware. We work with most of the hardware vendors, whether it's ABB, Schneider Electric, Honeywell, you name it. And we have some labs. I'm in Houston right now. We have an IoT lab here. You can't really visit it because of COVID, but I invite you to go to a Microsoft Technology Center where you can really interact with some of these solutions that you see out here and work with these partners to start testing this end-to-end hybrid, I call them hybrid solutions, and see if they fit your strategy. And as you look at the ecosystem, when I first developed this slide, it was 2019, and we were looking at the things that would drive the industry back then. And then we look forward into 2020. Most of what we predicted in 2020 came to happen. Now, looking forward, we are looking into more development of things. What are some of the themes, the new developments that will happen? It's going to be advancements in sensors, in robotics, in all these solutions that you will see in a typical OT environment. Our recommendation is that you partner with your solution providers and don't treat them as vendors. There is a saying that vendors will bolt in, partners will build in. You want them to build these things into your environment, not bolt them in as an afterthought. Just my recommendation. I've seen that to work quite significantly. So sensors, data analytics is going to be key. We see that as the next, pretty much it's going to be big. And I invite all of you to work with sensor providers to influence the direction of all of that. This is an example of a sensor that we jointly developed with one of our our vendors, and we built in the various metrics that we wanted to see from under the earth, whether it was pH probe, temperature probe. We wanted to see everything, water. What we wanted to measure the cleanliness of water, right? In this case, we're trying to solve E. coli problem that was breaking out in a region of the world. And we brought in this solution, worked from the ground up, built it into our sensors and deployed in the field. So that is an example of how we see this going forward. That was my last slide. I want to thank you guys for listening in. I will say that the future is great when it comes to the water industry. As I just said earlier, we are the ones that will make sure that the next century is not one that water will be the reason why people go to war. Thank you very much.
Thanks, Jovita. Excellent discussion, and I love all these presentations. They're all subtly different with a good tie-in. So our next speaker is Kenji Takeuchi. He's a senior vice president and technology solution provider for Mueller Water Products. For those of you keeping score at home, he's also a graduate of UC Berkeley. So I think Berkeley and Purdue are currently tied in the university challenge here. His talk is going to be focused on developing advanced sensors, IO technology and platforms. And he's here today to talk about how these sensors can be used and how these tools can be integrated into smart cities and the smart water ecosphere. So with that, I'll give it over to Kenji.
Thank you. Yeah, I definitely had to mention Go Bears, but my undergraduate was Georgia Tech, so go Yellow Jackets if there are any out there, since that seems to be what we're doing. Yeah, thank you. It's interesting going last because it's kind of validating the content that I have or was prepared to talk about, but it's also very repetitive. But at that point, I will try to not be repetitive, but it's really good talks, and I like to see these commonalities that I will also point out. I mean, to start with, I want to maybe give you a little bit of background of our perspective. Mueller is a 160-year-old company. We are squarely in the digital transformation, digitalization, and our background is, as you can see, we're fairly broad as a strength within the water network, in the water infrastructure. Probably from a brand perspective, we're very well known for our fire hydrants, valves, but we do thousands of miles of pipe condition assessments and repairs, and traditionally a manufacturing company. But over the years, we've been investing in sensor technologies and smart technologies, and our data strategies and software platforms. So again, very similar to what we talked about. I think the big problem is that there's a lot of reasons why there's a lot of things we need to spend money on. Pipes are breaking faster than we can repair them. The capital spending is actually not increasing as fast enough to be able to repair and spend as much money as we need to. So there's an increase in operational spend, OpEx, and that increase in OpEx then needs to be focused on optimizing, making better decisions, making better insights about where do we spend the money, which is a lot of like what Jim was talking about, with better insights and better decisions being the goal. And so yes, we see the same goal, and so the way that we approach this problem is taking advantage of our physical infrastructure that I showed you, and then creating a intelligent software platform that we call Centrix. And so, I think maybe I'll continue to focus on, the success of this ecosystem is for us to be able to get the data and get the sensing information from the water network. So, again, maybe a very simple, almost cartoony, but just to give you, some ideas about the things that we want to be able to do within the water network, leveraging our Centrix intelligent platform. If you're a water meter, we have the ability, obviously, to measure the water flow and be able to detect leaks. But yes, we also want to be able to close the valve. So we have a remote disconnect meters connected to the Centrix platform. So we want to be intelligent about and create these actions and insights. If you're a valve, you would want to know if you're open or closed, and what kind of water quality are you seeing, or what kind of flow you're seeing. If you are a fire hydrant, you can monitor your pressure and be able to detect leaks, and then close that loop, which I'll talk to you about a little bit. Our water quality stations, if the chlorine levels are off, or if any other contaminants, you would like to automatically flush, and as well as our control valves. If the pressure is off, automatically adjust your pressure as needed. And so the overall way we look at the system is, again, identical to the way we've been talking about it. If you go from left to right, the left is our sensing and actuating. So these are the physical, the lower layers of the swan deck, the data that we collect. I think Sunil was calling it the data collection layer, and Lindsay was calling it the sense and then predict, and as well as Shashank also showed the harvesting the data. And so on the left, you have the data, and then in the middle, you have Centrix. This is where we aggregate that data. And again, everybody had this concept of the data fusion and the aggregation of that data, and then creating those insights, creating visualizations of that data. In our case, in the top left there, we have our flow data, we have leak detection, acoustic monitoring, pressure, temperature, water quality. We want to ingest that data. We want to do data fusion within our Centrix platform, and we want to make insights. I think, again, a really great comment that Jim Cooper said about the collective intelligence, because I didn't really put the term to it, but that's why very prominently on the right-hand side of our document of this slide is the water network administrators themselves. They are the human factor. They're involved. They're the persona that is involved in this closed loop process. Is the asset managers, making decisions about where to go make investments or where to go, plan for your future assets, and the field supervisors making sure that we can react to the maintenance and operations and digital workflows necessary. And then that it's all fed back into the physical world with our, with pressure control capabilities, with valve positioning, flushing, or even sending the mobile technician automatically through the workflows and through automation and back office integrations. So I think the vision for us is to have our Centrix platform make these, collect these data, create the data fusion, and involve the human in this collective intelligence and make decisions so that we can spend the money, our very limited, capital expenditures on the right places at the right time. So a couple of solution examples. Let's just take leak detection and how Centrix and our AI and insights can help. I think it's fairly clear why we want to fix leaks quickly and fast. But with the ability to use our cloud platform, our analytics and machine learning engines, we're able to then take these acoustic signals, we call them these noises, and then characterize those as persistent noises that are possible leaks, and then narrow down again through automation and through our computing and insights to areas that we really need to recommend to send field workers and attention to. And so this is the value that obviously that doing this data integration and artificial intelligence can really help assist. But if you add on to just that data, and we'll call that proprietary data in this sense, and add public data and utility data from our customers, we're able to do things to a next level. Not only can we say, hey, how can we use these insights to predict or to find leaks and accurately characterize where we need to put our valuable resources, but also how do we be able to predict which pipes are going to break? What is the likelihood of those failures? What are the consequences of those failures? And the math between the likelihood and the consequence. If the consequence is very high, if it's in an area where a leak or flooding has a great consequence, like hospitals or industry, or in areas of that flood could be very damaging. Using the next level of intelligence is something that we've done with what we call PipeRank. And again, a very quick case study to discover, for a particular customer, we evaluated their thousands of miles of pipes. We're able to accurately predict 17 of the ones that have failed or will fail through that data. And then there's this 18th one that ended up failing shortly after the study. So I think it shows that being able to predict which pipe is about to break is an excellent way to save your capital expenditures and put them in the right place, and an appropriate way to spend your operational expenses. And so this is a new way of thinking for many of our customers. I'm going to finish with again the idea about really having a powerful insights engine requires again, I think it was much like what Shashank said. You should work backwards. The problem statement here is how do we optimize our resources? How do we help the collective intelligence of our asset managers and our field supervisors? The ability to do that requires us to then go moving backwards into aggregating that data and doing the fusion, and then moving backwards into collecting that data. And so when we think about how can we, what is our strength, where Mueller is very strong with infrastructure and in our devices and in our physical infrastructure out there, where could we help bring the most communication? What points in the water distribution network would be a great place to create communication, gather data, from sensors and then send it back up into the Centrix cloud. And I think the kind of the obvious thing is the hydrant. They're visible. They have line of sight to at least to the wireless signals and communication signals. And so our approach is and we've been launching this. We've launched this, and we're going to add on to it. But is to think about the hydrant as the communication hub of the of our smart data water network. So from here we can use the existing infrastructure. We have millions of hydrants out there, and we're able to retrofit with ours and in the future with any fire hydrant out there. Measure the pressure. Again, we can get into why measuring pressure is so important in terms of water quality, in terms of service and customer satisfaction, as well as extending the life of our pipes and other assets, but measuring leaks from these. And again, creating a communication hub where we can work with our open APIs, connect with third-party sensors, not our own, and create that data layer that feeds into the insights and the value to the end customers. And this is going to all be built off of our Centrix platform. And we think of our smart hydrant as that data gateway and communication hub to the water network. And so I will probably end it with that and see if there are any questions.
Great, thanks, Kenji. Yeah, so with that, I think we're starting our the portion of the discussion here and kind of open it up to questions from the field. We've got the chat window. No one's asked a question yet in the chat that I see, but if you have a question, maybe raise your hand. And Kathy, I don't know, do you need to unmute people as they go?
Folks can unmute themselves if they would like to ask.
Perfect, so you can unmute yourself and ask a question of the group. So just let us know if you have anything. If not, I've got a couple questions we can start with. Okay, well, not hearing any questions, I'll go ahead and ask a question to the group. So I mean, obviously these are, fairly, we're talking about, fairly advanced techniques and philosophies, and then, sensors and things that are, that are probably very, obviously very useful to the industry. But, what do you all see as you've, helped develop these things and then help to implement them and work with utilities and regulators and everybody in the industry here? What have you seen as the stumbling blocks, right? Or the skepticisms to these technologies? Is it the cost? Is it a lack of knowledge, or just a perception that these technologies are hard to implement? Or is it that we maybe need to work on our industry and move it more to, as Dr. Burt showed, the left-hand side of the adoption thing, moving a little bit more to trying to be a little bit more innovative instead of being staid in our thinking. So, I know what does the panel think?
Hey, James, I've got a thought on that. It's kind of interesting to think about what we're all doing here right now. We're all on a Zoom conference, having a virtual conference, right? And it's actually working pretty well. We're chatting and all this type of stuff. The interesting thing is this technology has been around, but we didn't use it in the past. It was people and some sort of massive paradigm that required a change, and now here we are using it, right? So I guess my comment, or my response to your comment, is that it's really not about the new technology. It's really about the people and getting them to use that technology, right? And there's many different technologies out there, many to be innovated yet. I really think it comes down to each of us individually deciding to make a change and deciding to adopt technology is that primary headwind that I see most cases. Other than that, obviously financial is a key piece of it, right? And I think that's starting to go away as we see some proven business cases and see that the initial implementation costs for some of these advanced technologies really do have a low payback period. But that's probably second in my mind.
Mm-hmm. Good points.
Yeah, I totally agree. If you can't portray the technology is helping somebody's daily activities, it's really going to be hard to convince them, yeah, this is something I really want to adopt. And if you want that stickiness, over the long term, it really needs to be understood by the staff, and then also adjust your fundamental workflows and business processes to leverage the best of what that technology can provide. Again, there's so many people that focus on that shiny object, but the shiny object is only good if it's embedded into daily activities.
Yeah, and
And I would add to,
just yeah. Sorry, go ahead. Go ahead. Go ahead,
and
Lindsay.
I would add,
Yeah.
I think Shashank, you actually said that, demystifying digital, right? So oftentimes it's just, talking in lame, simple terms and pulling out my iPhone and saying, if you're using
Exactly.
Waze,
Yep.
if you're using Google Maps, that same technology is what we're talking about, but in broader scale. And to add to that, I think, one of the larger stumbling blocks from utilities is this autonomous versus enabling informed decisions, right? There's a skepticism that neural networks, digital twins, this decision intelligence will just take over my utility rather than it's going to enable you to inform and making better decisions. So I think some of our panelists talking about that, but really still education. There's still some attitude behavior changes, and that's okay, right? That is that paradigm between early adopters and late adopters. But I think we're seeing that shift now ever before, especially with this unprecedented time.
Yeah, and just adding on to that, right? So, again, I come back to the same point that digital doesn't have to be so complex. I have worked with utilities who were recording data on manual documents, and we have helped them digitize that data back and create a kind of a server environment for them to bring that data back, and and then they have had an aha moment in terms of, oh, okay, so this is how my data looks over a 1 year period. I think we need to start simple. Let's get very simplistic, because there are a lot of utilities out there who don't even have the knowledge of digital right now. And we need to help them with good data collection, help that data collection perspective go in place, help them realize that where the data collection will help them from an analytics perspective. We work with a very large client up, in upstate New York, just to get O&M manuals digitized. It's such a simple example, right? It's kind of not the flashy stuff that we've talked about today, but it's so simple, right? How do we digitize the O&M manuals so that we don't have archaic library collecting dust? Somebody doesn't know which manual to address or pull out for an asset. So that's just my message. Let's start simple. There are going to be clients on the maturity curve. There are somebody who is very far on the maturity curve. But there are quite a few water utilities out there in North America who are not on that curve. And yep. So glad to help.
And I know I'm going to repeat myself from yesterday. Anybody that was on yesterday, but our philosophy about technology adoption is, again, I'm going to butcher it like I did yesterday, but Steve Jobs had a famous quote about saying that you start with a customer experience, and the customer value, and you work backwards from there to the technology necessary. And if you start with the technology and looking for a way to sell it, that's the wrong way to do it, and you will fail. So
I completely agree, Kenji.
So
Absolutely.
Real acceptance, requires you to sit down with the customer, really understand their workflows and the problems you're solving. And so, this
Right.
innovation, this joint ideation, I think is key. And it's that whole working backwards philosophy.
Just one additional comment on that. I feel like we all, right, a lot of us here, we're probably, preaching to the choir, right? We all get the basics of some of this. And I've seen a lot of utilities adopt and implement various advanced technologies, and it's quite impressive. I think that we generally would agree that, things like removing data silos and allowing utilities to get more insight and information rather than looking at raw data is critical and important. But I've also seen utilities that are almost having the opposite happen, right? They are looking at new technology, and there's a lot of vendors and startups out there, and so they're adopting these different technologies, and as a result they end up creating more silos within each one of these individual groups than less. So I think that's something we all as the water sector really need to focus on, is how do we really integrate these? And 2 or 3 years from now, we're not sitting here saying, gee, now we have all these wonderful technologies, but they're all siloed, and we don't know how to get them to work together.
Point. Great. Well, we do have one question from the group, unless there's anything more on that. That's one of the speakers, I think it was Javita, talked about some of these and practices coming from other geographies, right? So we're obviously the United States, although we've had some people here on the conference from other places. But how do we see, and leverage some of the best practices in other places like Singapore, Israel, Europe, and Australia? And then also, are there differences and things that we need to keep in mind when looking to adopt those things, either on the IT spectrum or just in the industry as a whole? What is the panel seeing?
Well, we have this concept of lighthouse projects that kind of provide that beacon in the darkness to allow folks to understand what's out there. Those lighthouse projects, because let's be honest, the water industry is not exactly a forward-leaning industry. So it is going to take some of these more forward-thinking utilities to provide those lighthouse examples. So Singapore PUB is a great example of it. They are definitely setting the trail for a lot of the implementation of technology that we talked about today, and they are sharing their benefits. They have a great white paper out on digital water that's available to all, that kind of sets their journey, and it's that information sharing that's going to be critically important, because again, utilities don't want to be the first one to really implement something, but if somebody else has done it, then that light has to follow is great.
Yeah, I couldn't agree with you more. I mean, global utility exchange is critical. Many utilities would love to hear from others, and we've worked on projects from treatment optimization in Europe and deploying that technology here in the U.S. The data is still, the science is still the same, but there's different drivers, right? Regulatory drivers may look a little different. Stringent effluent regulatory compliance in certain regions of the U.S. looks different than Europe, but we're able to deploy some of those technologies that we're doing in Europe in the United States. That's really exciting. And then this international data exchange, working and learning from others, whether it be East Asia and others, and deploying that technology where it makes sense. I think the bottom line is, I think it's said before, it's not the technology. The technology's been around for a while. It's asking, what is the problem we're trying to solve? And then how do we develop a digital roadmap, right, for the utility? How do we work with them in that? And so learning from others across the globe is critical. And that's what's exciting working in Xylem, that we have offices all over the world. So being able to deploy not only the sensor technology, but develop those platforms and learn from others, I think it's critical. So that's what's exciting about water. Utilities love to talk to other utilities. And so there's a really opportunity for learning during this digital transformation space.
Yeah, and just, sorry, go ahead.
No, I was going to say great points. Go for it, Shashank.
Okay. No, I was just going to add to Lindsay's comments. So those were really, those were really thoughtful. So the only thing I would add here is, from an overall perspective in water, we need to understand that the North American market is a bit complex, right? So we have close to 50,000 water utilities in North America. And quite a few of these, close to about 15 to 16,000 utilities, are catering to less than 500K population. So I think the challenge from a digital perspective, and I know that all of us are digital leaders here on the call, but how do we get digital to be working practically with those kind of utilities that serve less than 100K kind of population that make up most of the North American market? we can bring an experience from Australia, we can bring an experience from UK, because UK is quite advanced. You know, Yorkshire Water, Thames Water, Northumbrian Water, you know, I work with them quite closely in terms of their digital initiatives, and they're quite advanced, but they have the budget and the money to spend. So, so I guess what I'm trying to say is that, yes, there is a lot of value that we can add, but from a digital perspective, we need to nail down how we can help them. Is it simply automation? Is it simply putting a sensor? Is it simply a platform? You know, yeah. So would be excited to make digital real for those kind of clients. Yeah.
So we do have a question from the audience here. Magana has asked, are there experiences that speakers can share about their efforts in including small communities, water resource managers that would be beyond utilities, and energy providers in their digital solutions? And I think that's kind of what Shashank was just mentioning, right? That, you know, I think this is very much, is there's something that we can do, since all of this is digital, is there something we can do more on almost the smart cities platform, right? We're talking smart water, but when we're talking about smart cities, we're talking about the balance of that whole ecosystem with energy, in small communities. You know, we're not, you know, you may have, you know, cities of different sizes, large cities, small cities. How have you seen and how do you think in the future, say 5 to 10 years, we're going to be able to leverage these technologies to, you know, to bring those economies of scale down maybe?
Well, one of the things that I enjoy about my role is I'm digital across everything that Jacobs does. So our 55,000 employees, you know, work in the power sector, work in the transportation sector, and being able to connect what's happening in those other verticals back into water is really an interesting thing. You know, with regards to those small communities, one thing that we're seeing is the cloud is really lowering the barrier to entry of a lot of this technology. I mean, Jovita talked about some of that, and we're certainly working with Microsoft to implement some of these solutions that can be made available to the breadth of communities that may not have the resources out there. You know, that whole, right now, the energy nexus that we're seeing out there in terms of transforming into renewables is a very interesting connection back into the water sector. Pumped hydro all of a sudden is going to be a thing for energy storage. Well, that has huge connections back into the water side of the fence. Harvesting energy out of the wastewater treatment process, another great renewable that can really drive into that energy play. So, you know, connecting those pieces that we're seeing in our other verticals is hugely impactful back into the water side of the fence.
And I would add
maybe
to
I'll
that
talk.
too, Roger. Those are good points. I would also add to that we're seeing the cost of sensors go down dramatically. And so when you think about smaller communities, even farming communities, you know, that's really critical. There's an opportunity now to deploy digital intelligence for farmers. And what does that look like? What's realistic? What's feasible? But how can we deploy, you know, digital, not only sensors, but even the lily pads I think we saw in the presenters, one of the presenters, but I'm working with farmers now where we're looking at deploying that technology as well and bring that digital intelligence at their fingertips so they can make informed decisions on an agriculture basis. So I think it is critical to explore how technology is impacting smaller communities, farming communities, lower economic communities, and how with cloud integration as well as low-cost sensors, there are opportunities to look and explore that more.
Yeah, and when we think about our R&D activities, you know, whether it's a small community or even like residential, I mean, we're looking at, you know, doing residential level water quality monitoring, residential or building, you know, at an apartment or a hospital or an industry level treatment capabilities for, you know, those particular contaminants that you're worried about. So I think that like you said, you know, Dr. Burt, the cost of this technology is getting so scalable that you can now start looking at these technologies being more at the edge of your water networks, whether they're residences or a multi, you know, unit kind of dwelling places or hospitals and places like that.
Yeah, and just just adding on to that comment from Lindsay and from Kenji as well. So as a water utilizer, so I'm a customer for my utility in Pennsylvania, right? So when I look at my water bill, I would like to understand how, can I get that in a mobile application? Can I get an alert in terms of whether my water bill has come in time? What are the features of that water bill that help me understand where I'm using water rightly in my house? So when I get a Pico electricity bill, for example, I'm able to understand very clearly where I'm spending my energy, whether it's gas, whether it's electricity, what are the utilities in-house that I should be stopping on. But that is something for the water industry to look at. Digitally, we can enable those technologies to get outside the meter. So there is something inside the meter, which is the water meter and the AMI infrastructure or AMR infrastructure that the water utilities have implemented, which will get to your house. But inside the house, in terms of how we are consuming water, that's still a gray area for us. And, I'm hoping that as a technology perspective, we can get to that. Because if we do get to that, then, I would, as a consumer, I would love to subscribe to those services because, like I know where exactly I'm spending my electricity and how do I decrease my thermostat in terms of electrical energy. If I could do the same with water, it would be amazing. So that's something that I'm working on, but yeah, more to come.
So maybe I can just provide one comment on the small communities or small utilities aspect of the question. The comment was, right, are there any experiences with those small communities? And when we talk about advanced technology in the water sector, often it's a very high level discussion. And there's a reason for that, right? Because with the 50,000 utilities that Shashank mentioned, which is the exact comment I was actually going to mention, the where those utilities sit on their adoption and maturity for some of the advanced technologies widely varies, right? It really comes back to what Lindsay was talking about as not what can the technology do, but what are their needs. So you could apply a vendor technology to a very large, mature, advanced utility in the US, and they have some certain needs for that, right? There's probably something that their existing platforms couldn't do or they couldn't interoperate, right? That same technology could be applied to a very small utility and is being applied to very small utilities with an entirely different value proposition, right? It could be simply to visualize the data since they're all at home so someone can see the data on their phone, which is entirely new to small communities. So it really depends on the community, but I think when we talk about this stuff, that's why it's high level, because there's just this wide range of how the technology can be applied across the sector.
Which is a good thing in that, it means that, it makes it much more scalable. Since it is more, agnostic, but it makes it harder for some agencies to adopt or see themselves adopting. And I know there's some discussion in the chat about somebody saying that, well, internet in rural areas is difficult. And I know Javita was talking about technologies in Africa and some more rural places like that as well. But we're talking about the United States, right, that still has issues with internet. And so as we look to these, Raja mentioned that, there are broadband services obviously coming out with satellites, right? The question is, when is that going to happen, right? When are those satellites going to be up there? When are they going to be broadcasting? Or is there something that we should be doing as part of our, as leaders in these technologies, helping utilities looking to implement them? Should we have, a good play sheet for them to kind of lay out the future, right? This is when you're going to have internet. So this is when you need to be thinking about, looking at how you're going to adopt that. And then are there things they can be doing with their data now in systems that aren't necessarily cloud-based systems, but at least are setting the stage, right, for these utilities to be able to make sure they're doing proper data collection and things like that. I mean, has anybody in here seen or looked at maybe that sort of future timeline and in their their journeys there and implementing things?
Yeah,
So I guess just a,
go ahead.
go ahead, Raja. No, I was just going to say a real quick comment is that I think that's the value in this engineering research center on Smart One Water, right? Is bringing together these various scales and spectrums and enabling some of those utilities that may see this, you know, this massive topic of something like intelligent water and just fail to act because they don't know where to start, right? And so I think that, again, that's one of the takeaways I have from this conversation is that's a key functionality perhaps of the Smart One Water Center.
Mm-hmm.
Yeah, so James, I mean, back to the
sorry, go ahead, Raja. Yeah.
James, back to the timeline perspective. I mean, as Jovita talked about, there's a compression going on right now. Things that used to take years, if not decades, are happening monthly. Jacobs is actually involved in launching some of those LEO, low Earth orbiting satellites right now. That is going to be happening here within 2021. You will have that service available. So that type of connectivity, not only is it helping the rural side of the fence, but it'll be interesting to see what it does with regards to smart water networks. The ability to monitor in locations that you really could not monitor before, you know, way up there in the watershed, and get insight into that. Really excited about the potentials that can really drive some savings and operational efficiencies downstream back into the distribution network.
Good stuff.
Yeah. So just one comment on the question that was, or the opinion that was shared by Bookie in the chat. No, I just respect the entire experience that you had, Bookie, and I would just like to say that I think from a digital perspective and a water perspective, we are making the biggest impact with these smaller utilities. We are making them realize that what technology can help them. It could be a utility just serving, you know, less than a 50K kind of a population. And so that's our endeavor. I don't think we need to discount them. They're also interested. They're also under pressure in terms of, you know, employing and enabling technology landscapes. So yeah, I would not discount them.
Yeah.
Okay.
And I think, you know,
James,
we're getting close to the end here, right?
Yep. We are close to end. Yes.
Yeah. So
let's give big applause to all. It was really very great.
Thanks, everyone.
Okay. Thanks, everyone. So now we are in the break session, and as you know, in the break we have a sponsor speaker. We have a schedule. So as you are taking coffee or whatever time zone, we have a speaker. Let me pull mine. So Xylem is the sponsor for this break. And Christine, you are available? Christine Boyle.
Hello, everyone. I am.
Perfect. So let me introduce you as you are pulling your slides. So Christine Boyle is the Vice President of Business Incubation at Xylem. She works with entrepreneur innovators to bring the next generation of water technologies. So that fits very well with what we are talking. She received a doctorate in water resource planning in 2011 and spun a water analytic company, Valor Water. One of her thesis work at University of North Carolina at Chapel Hill. A lot of different universities represented actually today. She is vice chair of Cal Nevada American Waterworks Association and a trustee of American AWWA Management and Leadership Division. Welcome, Christine.
Thank you, everyone. And I pre-recorded my session, so I'm going to ask if Kathy doesn't mind to start the recording.
Not a problem. Actually, on Mom, you're up.
Yeah, I'll do that. Yeah.
Thank you.
I hope you're able to see the video.
Are you playing video? Yes.
Yes,
I've not started it yet, but can you see?
Yes, we can see.
Okay.
Hello, everyone. Welcome to this session on fostering a culture for innovation. My name is Christine Boyle, and I am Director of Metering Insights at Xylem Inc. Many thanks to our hosts, the 2020 Virtual Swim Conference. It's a pleasure to be here and excited to spend the next 15 minutes with you talking about innovation. At Xylem, we have our main motto that we live by is let's solve water. Xylem is committed to creating economic and social value across all of our stakeholders. That includes and is not limited to our employees, our customers, the communities we serve, as well as our shareholders. And that's why we've made Let's Solve Water kind of a key credo that we live by. We're helping to create a world where water issues are no longer a barrier to human health, prosperity, and sustainable development. We also are working hard to create a world where water is accessible, affordable, and safe for all. We also know that the tools that have helped us create a sustainable water world through the 20th century are different than the ones that lie ahead of us for the challenges of climate change, massive populations, as well as the opportunities we have with new tools, such as advanced sensoring technology and machine learning and AI. We are committed to achieving this lofty goal, and innovation is one of the ways that we can do that. Again, my name is Christine Boyle. I am an inventor, an entrepreneur, and trained as a water economist. I'm also a Xylem team member, and within Xylem, my purview extends into two main areas. One is helping foster early stage technologies within Xylem. Think digital twin, flood control, advanced pressure management. I also help scout new and emerging technologies by other inventors and startups at companies and universities. Think of PFAS mitigation or distributed water treatment, both really important things. These are all important, and we're going to talk through a little bit about how an organization such as Xylem and hopefully yours can help create and foster an environment for innovation. Now, a little bit about Xylem. We're a large company operating on all 7 continents, 16,000 employees, and revenue of just over $5 billion in 2019. We provide many different types of technologies across the urban watershed and across the watershed in general. We are able to, with our technologies, treat water, transport water, provide advanced analytics on the water that you want, which is obviously fresh water, and the water that you're trying to get rid of, whether that be wastewater or flooding water. We have a strong brand legacy that goes back over 150 years with many highly trusted brands. Think of Bell & Gossett, Flygt, Godwin, some of our pumping and treatment technologies. Now, Xylem was founded in 2011 by kind of aggregating a lot of these and splitting off from a previous company. But the heritage goes back far, and we're just getting started. In the last, 10 years now, Xylem has marched forward in acquiring a number of advanced technology companies, such as Sensus for their communications and metering technology, Mnet for flood control, and Visenti for pipe and leakage management. We have scouted the leaders of innovation across the water sector. And as I mentioned before, we continue to do so and innovate both externally as well as internally. Now, our innovation ecosystem is actually all-encompassing. I mean, first and foremost, we go to our customers to learn and help them solve problems. This is where all great innovation starts, is with solving problems. So we work with our customers to innovate and iterate on solutions with our customers. We also partner with universities, most notably right now, Arizona State University, as well as MIT. And we'll show you a video in a second, a little bit about how we've partnered with universities. We also have partnerships with federal governments and state governments, technology partners that bring us pieces of technology that we don't have to again, help solve problems for our customers, as well as working with startups and NGOs. Now, all that together, we've in 2019 managed to spend $191 million on R&D, showing that we're putting our money where our mouth is. A couple of examples include our most recent wastewater pumping technology, the Concertor. Now this again was born from helping solve customer problems around reduction of size of the pump, the need and kind of expressed concerns over cost of energy, as well as the need to have a lower kind of inventory for replacement pumps and parts. So Concertor has been a really important piece of our pandemic response to help with clogging issues around in sewers and wastewater treatment. We also are very proud of BlueX Collections. This technology, you're going to see in the video more about its origins, but is a wastewater network optimization technology that specifically and most profoundly helps mitigate combined sewer overflows, as well as other kind of smart sewer systems through a combination of sensoring, advanced weathering, radar detection, as well as analytics and controls that'll help control everything from pumping to valve control and pressure management throughout a collections network. Now, again, cost savings versus standard capital intensive solutions is 50 to 70% cost reduction. Think of $100, that's $70 saved. When we think of $100 million, now we're getting into 8-digit figures that are very meaningful for communities, and we're very proud of this. So, getting back to the question of how to spur innovation, let's talk a little bit and watch this video that's going to show us how Xylem and Entrepreneur is working with entrepreneurs as well as universities and utility partners to spur innovation. This video is about 3 minutes.
Today, we face a growing crisis of aging infrastructure. Today, we face a growing crisis of aging infrastructure, a changing climate, flooding, and urbanization.
When you look at the numbers, whether it's aging infrastructure, sewage overflows, or affordability issues, it's clear that there's a lot of opportunity to help communities around the world manage water better. One of the things we've been excited to see is that a lot of local utilities and universities have been working together on these issues, creating some incredible startup companies to solve their biggest issues.
The City of South Bend and the Idea Center at the University of Notre Dame challenged postdoctorate graduate Luis Montestruque to develop a technology to reduce sewer overflows that contribute pollution to the local St. Joseph River.
This was really the first time that the city and the university came together to solve a problem that affected the city.
We, through the work with MNet, put in over 150 sensors into our sewer system. It's the most densely sensored system in the world. We were able to take a $700 million program, and for the same environmental benefit, not changing the level of service, do that for $200 million.
Researchers at the University of North Carolina and a consortium of 12 of the state's apparent water loss and recover lost revenue from faulty meters.
The work that the Urban Water Consortium did with the Environmental Finance Center spawned, Christine Boyle and Valor Water to develop a product that's really relevant and important to the issues that utilities across the country are dealing with today.
Well, Valor Water is committed to figuring out new ways, new applications of the data to provide insight to utilities so that they can help protect the water, so they can help protect their financial resources, and at the end, help continue to provide clean, affordable water to their citizens.
In the USA alone, more than 240,000 water main breaks occur a year, creating floods, service disruptions, and traffic chaos. Recognizing the costly problem, Singapore and MIT supported and brought together 3 postdoctorate graduates to develop intelligent monitoring solutions to find leaks and reduce the loss of water in aging infrastructure.
It is not only about solving these fundamental problems around the leaks and the losses, but the real end goal is to get this precious resource within the hands of the end consumers. So the entire social element is behind this intelligence and the real-time monitoring aspect that we bring to the table.
Thanks to solutions like these, I believe we can see massive changes in our industry. We're constantly on the lookout for solutions that are going to bring even greater value to the communities that we serve.
It is my great pleasure, and one of the wonderful aspects of being at Xylem, that I get to work daily with Luis, Mudasser, Mike, and Ami, the inventors of these technologies. So let's learn a little bit now and see these technologies in action. In-Revenue Locator is a advanced metering analytics application that helps utilities locate loss on meters, whether it be a meter is faulty or there's been theft on the meter. These types of things hurt the bottom line for utilities, and those problems are passed on to the customers. We have been working very closely with Clayton County Water Authority for many years now and help them identify over $1 million in recoverable revenue. It goes right back into sort of the budget that the ratepayers contribute to. So very proud of our deployments there and delivering a 4-fold improvement in identifying these meter issues for Clayton County and its citizens. We've also deployed in Orange County, and we've located over 1,800 metering issues that team is now investigating, leveraging their deployments in AMI technology to help really make the most of that data, understand where the problems are, so that their workforces know what is the highest priority for them to deploy their field services. Identified over 1 billion gallons of apparent water loss. Again, this is again the triple bottom line: helping the ratepayers, helping the environment, as well as helping for financial sustainability. My colleagues' technology that you saw, this is by a team invented by Mudasser, Ami Price, and Mike Allen, LeakView and SurgeView. LeakView and SurgeView is deployed globally. One great example of their technology is with Tuas Power in Singapore. They've helped reduce ambient transient magnitudes from 60 PSI to 10 PSI. That's a 6x reduction there. And since implementing these recommendations, they've had 0 leaks. Now think of the environmental cost of the water, the traffic disruptions, the potential property damage. These are meaningful, and these technologies did not exist 10 years ago and are being implemented now globally. So how can you create a culture for innovation? First of all, we work in a essential service, which has never been more important and recognized as it is now. And we are tasked with providing clean, safe, affordable drinking water to communities. So you have to create a safe space for experimentation, for idea exchange, and for testing. We want to focus on rewards for innovation, not just on avoiding errors. Experimentation, a very acceptable end of an experimentation could be that it failed, you learned, and you iterate again. So creating a balance where there's a space for innovation is important at all organizations to spur people to step forward with their ideas. Now we're all very busy, so organizations have their mainstream day-to-day operational activities, but you need to carve out time to spend on idea development, technology development, or process development. Think about a retreat, dedicated hours per week to research and development, and accounting for innovation in project planning. Maybe there's a spur of a project that is dedicated to innovation, or maybe you kind of keep a lane open in your project plan so that you can have one kind of experimental project running at all times. You also want to communicate widely your wins in innovation to keep your teams and your stakeholders up to date on progress. Even a failed experiment is a step in the right direction in learning. So keep people up to date so that you don't have kind of never-ending projects, but ones that are kind of moving forward and achieving the organization's goals. I've dedicated my career to helping solve water and believe that this is the opportunity of a lifetime and certainly the one for our generation and the next. Thank you for spending this time with me. And now back to the swim program.